All right, so we're looking at, hopefully it's done. Yeah, it's done. The review sheet for your Chapter 2 test, which you'll be taking Wednesday. And God forgive me because I'm really, really tired. So it's going to be monotone. Anyways, first one, sketch a graph. You shouldn't have any issues with this. Doesn't mean you won't. That's a down 3. That's a left 2. And there is your initial slope. So we're left to fall 3. And we're going to rise 2 and run 1. And of course we know it's supposed to be a V. At least I hope we know. Ta-da! All right, we have some basic absolute value equations. What's in here is either 3x minus 4, and that would be equal to this stuff over here, or what's in there is negative 3x plus 4. We've been over that a lot. At least last year when you include algebra 2 we have. So I do the distributive property, 6x minus 8 equals 2x minus 7. I subtract 2x and get 4x. I add 8 and get 1. So x is a quarter. Over here again, the distributive property, negative 6x minus 8 is 2x minus 7. I subtract 2x, it's negative 8x. That's supposed to be a plus 8, isn't it? Yeah. I subtract 8 and I get negative 15, so x is 15/8. All right, the next one has an inequality. I'm not going to let it bother me. I'm really not. I'm going to kind of do the same thing. I have 3/5 of 5x minus 3 less than 2x plus 5. Or I have 3/5 of negative 5x plus 3. And this time, still less than 2x plus 5. Now I'm going to fix this division by multiplication. 5 both sides. 5's cancel. 5 times 2 is 10. 5 times 5 is 25. Distributive property, 15x minus 9, less than 10x plus 25. X is on the left, numbers on the right. 15 minus 10 is 5. And 25 plus 9 is 34, so x is less than 34/5. I'm going to go through the same process again on the second equation. I'm going to 5 both sides. Still going to have 10x plus 25 on the right, just like I did. 5's cancel. Now I'm going to distribute that negative 3, negative 15x plus 9. I'm going to take away 10x from 15, that's negative 25x. I'm going to take away 9 from 25, which is 16. I'm going to divide by a negative 25, and that's going to cause the inequality symbol to flip. X is greater than negative 16/25, which, as far as I know, doesn't reduce. It says write your answer as an interval. Well, the small number is negative 16/25, and the big number is 34/5. That's how hard that is to do. It's not a hard thing to do. So there's 1 through 3. Moving on to 4. 4 is pretty easy. Take a number and plug it into an equation. You know, they give you an equation. If you can interpret it, it's y equals negative 0.823x plus 38.66. You don't even have to know anything about r squared. And all we're supposed to do is plug a 12 in. So let's plug a 12 in. What is this, the sit-up one? That's a lot of TV. Of course, that's been replaced by screen time on phones. 26.78, 1 decimal place, 26.8 sit-ups. All right, based on the data below, calculate the correlation coefficient. Your calculators will have been reset. You'll have to go to second 0, scroll to diagnostics on. I'm gonna hit that key right there because it has the D. And then just scroll down a little bit. Diagnostic on, enter, enter. See, we're gonna go to stat, edit. You should be playing along, by the way, instead of just watching. I know you'll say, I can do that, and then, you'll claim you went blank. It's really kind of a boring thing to do, but it's easy. I really don't have enough time to make sure I don't make any typos. Hopefully you guys study hard and figure some stuff out. You need a good grade. Hopefully this is it. Whew, finally. Anyways, after that, we go to stat, we go to calc, we do a linear regression, choice 4. We scroll down to calculate, and our R value will be that guy right there, 0.992. All right. Let's see here. The U.S. imports of wine in hectoliters for several years given below. Determine if the trend appears linear. If so, and the trend continues, and what your imports exceed 12,000 hectoliters. You don't have to do this by hand. You really don't. It's up to you if you want, but you don't have to. I'm going to make 1992 be year 0. I want you to make note of that. Even though I'm using a calculator, I'm still going to let this be year 0. So we have 0, 2, 6, 8. No, because I'm an idiot. This is 0, this is 2, this is 4, this is 6, this is 8, this is 10, 12, 14, 16, 17. All right. Those are the numbers I'm using. You could have used the years that are given, that's fine. Now, the first thing it talks about is this data linear? So we'll have to look at the scatter plot. And again, it's actually really simple to do. There would have been no issue had you chosen not to change the number. I was just trained to make numbers small, so. I guess you would say brainwashed, but whatever. Anyways, we're going to look at the stat plot. So second stat plot, and turn it on. And this is just to decide if it's linear. Hit zoom, 9 for stat. And I would say that's pretty linear. All right, I would say that's very linear. All right, now I'm going to go to stat, calc, linear regression. There is something you can actually do here, which is kind of nice. You can do store regression equation. Hit the vars key, y variables, function, y1. And what that does is that puts this regression equation into y1. I'm going to write it down, obviously, too, because I don't expect most of y'all to remember that. But I'll show you why I'm doing that. So it might be worth you trying to run through a couple times and memorizing. It might be. The reason I'm doing that is pretty simple. Because now I can put a 12,000 into y2. All right, let's take a look at the graph. I'm probably going to have to look up. 12,000 is going to be above 9,500 or so. So window, let's change the y max to be 13,000 so I can see that intersection. And I'll see the 13,000 line, but I probably won't see an intersection yet. So I'm going to have to look to the right. This is stuff we did in Algebra 2. Let's change the x max to be 30 years. 30 years will probably cover it. Okay, there's your intersection. Second, trace 5. Enter, enter, enter. So about 24 years, 23.83 years. Now that's after 1992. So 2012, 13, 14. So 2013 to 2014. That's when it happened, somewhere in there. All right, the later half of 2013. Now, compare and contrast that with the algebra that I'd have to do. All right. The algebra that I would have to do is just going to be kind of ugly. It's going to be 12,000 and actually want to exceed. So what is the equation? What does the equation exceed 12,000? 431.712x. Plus 1709.333. And then you would solve for x. And then add 1992. So you do it either way you want. I don't really care. I don't. Just get it right. Number 7. In 1994, the moose population park was measured to be 3140. By 1997, the population was measured again to be 3440. If the population continues to change linearly, find a formula for the moose population in terms of t, which is the year since 1990. So here t is 4, and here t is 7. So think about ordered pairs. You have 4, 3140. And you also have 7 and 3440. All right, so let's do your slope. Your slope is the change in y, which is 300, over the change in x, which is 3, which is 100, which means we gain 100 moose per year. That's nice. Now, if we go back to when time is 0, we would lose 400 moose, which should be 2740. because I had lost 400. All right, 4 years I lost 400. So now I can use mx plus b because this is now the y-intercept. So 100, let's see, this is time, t plus 2740. All right, use your model to predict the population in 2004, which means that time is 14. So 100 times 14, add 2740. It's going to be 1400 plus 2740, which is 4,140 moose. All right, number 8, suppose that the world's current oil reserves is 1,880 billion barrels. If on average the total reserves are decreasing by 16 billion barrels of oil each year, answer the following. Give a linear equation for the total remaining oil reserve in billions of barrels. These questions are all incredibly wrong in terms of the number of years since now. So our slope here is that we're losing 16 billion barrels. Let me say use T plus the initial 1,880 billion barrels. 15 years from now, the total reserves will be blank. Well, that's going to be negative 16 times 15 plus 1,880. Let's make sure I don't make any mistakes. $1,640 billions of barrels. See, if no other oil is deposited in the reserves, and we do find oil quite often, the world's oil reserves will be completely depleted approximately how many years from now? So we're going to set this over here equal to 0. And we're just going to do some simple algebra. So we got a negative 1,880 divided by negative 16, about 118 years from now. They want 2 decimal places, don't they? So 117.5 years from now. I think you'll be all right. I think you will be. All right. Now the question is, when does peak oil happen? That's the real question. You are choosing between 2 different cell phone plans. The first plan, blah, blah. The second plan, blah, blah. How many minutes would you have to use in a month in order for the second plan to become preferable? All right, so the first plan is 24 cents per minute, 0.24 M. The second plan is 44.95. This used to be a real thing, plus 9 cents. And I want the second plan to be preferable, so it's going to be the cheaper plan. And it's M's on one side and numbers on the other. And I made a mistake right there. That's 0.09, right? So anyways, I do a little subtraction. 24 minus 9 is, I hope, 15. You're going to do a lot of talking. Right at 300 minutes. And we're just going to say 300 minutes. It says round up to the nearest whole minute. So the minutes is greater than 300. That's not too bad. That's 5 hours of talking. That's really not that much. 10. This will probably be where I stop because I think second period's about over. Find the area of a triangle bounded by the y-axis. The line f of x is 5 minus 4/5 of x, and the line perpendicular that passes through the origin. So this one isn't a whole lot of fun. Most of you probably won't even draw it. Fall 4, run 5. And Anyways, that doesn't matter. Here's the original line. Here's the y-axis. And then we have some other line that's perpendicular to this one that passes through the origin. So they want you to find the area of this triangle, the y-axis, a given line, and then one that's perpendicular to it. So let's talk about the original line here. This guy was 5 minus 4/5 of x. Its slope is negative 4/5, so its perpendicular slope is 5/4. And that would be the slope of this guy. And this guy passes through the origin. So the perpendicular line is 5/4 of x. Okay. Now we're going to do some easy math. We're going to find out where they intersect. I'm going to take 5 minus 4/5 of x, and set equal to 5/4 of x. And I'm going to shift my x's over here. You're going to have to put those two fractions together. By all means, push buttons on a calculator, okay? It's entirely up to you. It's 25 and 20. I got 45/20ths in my head, which reduces, obviously, down to 9/4. We should probably check that, because I am a tired soul. 5/4 plus 4/5. Apparently I'm wrong. It's 41/20ths. Am I really that far off this morning? 25 and 20 is 45. Oh, yeah, it's 25 and 16. Anyways, we got 41/20ths of x. And that's equal to 5. I don't guess it matters a great deal here. 5 divided by 41/20ths gives me an x value of 141st. So I know the x value here is 141st. And that'll do it, actually. That's all I need to know. If I take this triangle and I change its orientation, it has a base of 5, and that x value is the height. Then I can just do area is 1/2 base height. So half the base of 5 times 141st. That's going to be 500 over 82. We can probably change that. Half of 100 is 50. So 250 over 41. Perfect. Yeah, I'm going to stop there because I got to go print off your MF quizzes and all that good stuff. But that's a good first start. I can finish up the rest of it during planning period now. Maybe I'll be more awake by then. Probably not.